Today's first question is majority element. We'll be solving 7 questions. And the first question is the majority element. Now, let me read the description for you. It is given an array nums of size n, return the majority element. The majority element that appears more than the floor of n by 2 times. You may assume that the majority element always exists in the array. So, what does this question say? Let's say there are 1, 2, 3, 4, 5, 6, 7, 7 elements, and you have to divide it by 2. So what we get is 3. So the majority element should be the frequency of the majority element should be greater than 3. Okay, so the problem is clear. Like, problem is to find the majority element in which you have to floor n by 2 times in an array, and we guarantee such an element always exists in the array. Now, for example, the given input is 3 to 3. Now the output would be 3 because it appears more than the half the time in the array. Similarly, for the input array of 2, 2, 1, 1, 1, 2, 2, the output would be 2 as it appears more than the half the time. So the solution to this problem can be like the first thing that comes to your mind is the brute force approach, and then we go for the optimized one. So what does the brute approach say? Let's check it out. So the brute solution is the naive approach. What are the steps we need to follow? We will run a loop that will select the elements of the array one by one. Now, for each element, we will run another loop and count its occurrence in the given array. Okay, so if any element occurs more than the floor of n by 2, we will simply return it. So that would be the brute approach, and its time complexity would be n square. And now comes to the optimized approach. So optimized approach, always take care of this one thing. Like, let's say if there is any question in which you have to find the frequency, or you have to just pick up this one element from given set of elements. So just keep in mind, you have to apply this algorithm, that is Boyer-Moore voting algorithm. Okay. So what does this algorithm do? Let's check this out. इसका intuition क्या है? If an array contains a majority element, its occurrence must be greater than n by 2 floor. Now we can say that the count of the minority element and the majority element is equal up to a certain point. Okay, so whenever we traverse through the array, we try to keep the track of the count of the element and element itself for which we are tracking the count. After traversing the whole array, we will check the element stored in the variable. Now, if the question states that the array must contain a majority element and stored element will be the one. If the question does not state so, then we need to check if the stored element is the majority element or not. If not, then array does not contain any majority element. Okay, so the approach is like, let me show you this. So what does this approach say? In it, we will initializing two variables, count and element, that I will show in the code. Now, the yellow colored element represents the current element. Okay, so basically in this, we are trying to keep track of the occurrences of the majority element and minority dynamically. That is why in iteration, look at these iteration. It is the first array. Okay, so in this, count is 0, element is null. Now in the first iteration count goes to 1 and count is 1, as 2 is the first element here. Now in the iteration 2, count becomes 2 because 2 was also present previously and it counted it as 2. Element 2, current element is equal to the element that is 2. Now for the iteration 3, count goes to 1 because we break the loop. Like there were 2 times 2 and now 1 has occurred. So we start the count again from 1 and the element is 2. Now the current element is not equal to the element. So now in the fourth iteration, what happens here? The count is 0, element 2, and the current element is still not equal to the element. We will again iterate 5 times, 6 times, and in the 7th time, we will get our answer, that is count 1, element 2. So in simpler word, you can understand it like if there are like these 3 elements. So the count, the num is 3, and 3 by 2 is what? 1. So if any element that is occurring more than 1 time, that would be your output simply, and that is 3. So this is the code, Moore's voting algorithm. Okay, so if you have any doubt in this code, you can ask me. Otherwise, it is very simple. You just have to initialize the size of the array, that is n, and you will take a count variable and an element variable. Okay, or we will traverse through the given array. If the count is 0, then store the current element of the array as element. And if the current element and element are same, and increase the count by 1. Okay, in this line. Now, if they are different, decrease it by 1. So this is the result we will return. Let me run it for you. And yes, it works. I'm not going to submit it because I have submitted it already 4 to 5 times. Now we will move to our second question, that is the majority element 2. And I have pasted this code for you as well. Now, this is the question majority element, that is, and it is way more similar like the majority element first, which that we have did. Now, what does this say? Given an integer array of size n, find all elements that appear more than floor of n by 3 times. Unlike the standard majority element problem, there can be more than one such element in this case. For example, in the given input array nums 3 to 3, the output would be 3 because 3 appears more than 3 divided by 3, that is what? 1 in one time in the array. Also for the same input, nums where is equals to 1, the output is 1. Since 1 appears more than 1 by 3 times, that is 0 for sure. Now for the input array 1 and 2, the output would be 1, 2, as both elements appear more than 2 by. Here the elements are 2 and 2 by 3 is what? 0. So these both the elements are, their occurrences are more than 0. So we will return 1 and 2 simply. And this is also the extent of Boyer-Moore's voting algorithm to handle cases where there can be multiple majority algorithms. Okay, so the brute approach would be, here we simply find that there are 1, 1, 3, 3, 2, 2, and count the frequency 1, 2, 3, 4, 5, 6, 7, 8, and 8 by 3, that is 2, and something which is more than 2, we have to return it, that is 1, that is 1, 2, 3, and 2, that is also, its frequency is also 1, 2, 3. So we will return 1 and 2. Okay, so this is the brute force approach. So like I will explain you this brute approach as well. What we will do, we will run a loop that will start the element of the array one by one. Now for each unique element, we will run another loop and count its occurrence in the given array. Okay, if any element occurs more than the floor of n by 3, then we will include it in our answer. While traversing, if we find any element that is already included in our answer, we will just skip it. Okay. Now, if we closely observe in the given array, there can be maximum of 2 integers that can occur more than the floor of. So, what we will do, assume there are 8 elements in the given array. Now, if there is any majority element, it should occur more than the floor of 8 by 3, that is 2 times. So, the majority of the element should occur at least 3 times. Now, if we imagine there are 3 elements, 3 majority elements, then the total occurrence of them will be 3 by 3, that is 9. Okay, that is greater than the size of the array. But this should not happen. That is why there can be a maximum of 2 majority elements. Okay, and the time complexity for this code is n square. And it can be optimized because n square is not that considered that good. So the optimized code time complexity would be O of n. I will show you the code later. First, I'll explain it, the optimal approach. So in this approach, initializing 4 variables is the code. Okay. Yeah. Like there are many approaches for this one as well. The thing that comes in our mind, that is unordered map. Like every algorithm, applying every algorithm, every data structure has some tricks. Okay, let's say we have applied Boyer-Moore's algorithm in the previous question because we were seeing that there are the repetition of number and we have to find any one particular number. So we applied that particular algorithm. Now for the same, this is also the same question, but we have to optimize it and the time complexity should be in the constraint. So we will use here the unordered map, and unordered map are the best for in such cases. Okay, so what we will do, we will initialize a store that from 0. Okay, store is declared but not used in the rest of the code. It can be removed or ignored or whatever. Okay, and now an unordered map frequency declared to store the frequency of each element in the nums vector. The key is the element and the value is the count of the occurrence. Okay, that's why we have taken int and int. Now, a vector result is declared to store the elements that appear more than the floor of n by 3 times. Here we did this. Now, for the loop, this loop iterates over each element in num and increment its count in the frequency map. Now, there's this variable n is assigned the size of the vector nums. Okay. For this loop, this for loop iterates over each key pair value in the frequency map. If the frequency of an element, that is I dot second, this one I dot second, is greater than the floor of n by 3, that element I dot first is added to the result vector. Okay, the function returns then the result, and we got our answer. That is the end of the solution and the class and the majority function. Okay, so let's run it. Yeah, it is accepted. So if there's any doubt or I'm not able to, explain it, so do let me know. Otherwise, we will move to the next question. That is, so this is unique path. There is a robot on an M into N grid. The robot is initially located at top left corner, that is grid 0 by 0. The robot tries to move to bottom right corner, that is grid M minus 1, N minus 1. The robot can only move either down or right at any point in time. Given the two integers M and N, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test case is generated. अब इसमें करना क्या है? The problem involves a robot navigating a grid size. Okay, M into N. Like robot have to go to this finish point. Like it can go this way. It will take right, and bottom, and then it can also go like bottom, then right and bottom right. So there can be many possible ways. For this question, uh, M is equals to 3, N is equals to 7. The output would be 28. Okay, so how this output has come? Let's check it. For an example, okay, so for this we have to use the brute approach is the recursive one. Okay, and uh, okay, so the brute approach is the recursive one, and the time complexity is the exponential. Ma'am, sorry. Okay, so the brute approach for this question is the recursive one. How we will find this? Let's say there is a grid M into N, that is 0, 1, 2, and 0 and 1. There are two columns, 0 and 1, and three rows, 0, 1, 2. So how the recursive approach works? Let's say we will initialize 0 by 0 as I and j, and what's the possibility? There could be two possibilities to go from 0 to 0. We can go from 0 to 1, and we can go from 0 to 1 here also. Okay, 1 to 0 and 0 to 1. From this side, 1 comma 0, from bottom we can go right, and the other one, that is 2 and 2 comma 0, and 2 is the last point. So we will return 0 because you can see there's no second row. Okay, and in this side, 1 comma 1, from 1 comma 1 it is there is also one possibility we can go to 1 comma 2. So we will initialize it as 1 comma 2 and 2 comma 1, and 2 comma 1 returns 0 because there's no going back, and 2 is the last point. And from this side, 1 comma 2, we will return 1 as we have reached the end point. Okay, so now in the recursive approach, you all know that 0 plus 1 is 1, and then 0 plus 1 is 1. So we got our first answer, that is 1 from the left hand side. From we go to bottom and then right, and we got 1 as our answer, and we will temporarily store it. Now the second could be like we will go to 0 comma 1 this way, the right hand side, and from there we can go like first is this 0 comma 2, and the second one is this 0 comma 1. Okay, so there are also two ways that are possible here. So we will first check for the 1 comma 1, that is I and j, and from 1 comma 1 we can only go to one way, that is 1 comma 0. And if we found the last element at its right place, that is the end point, we will return 1 here. Okay, and 0 plus 1 is 1. We are at the point 0 comma 1. Now from 0 comma 1 we will go to we have approached this one way, and now we have to go to this 0 comma 2 second place. Now from 0 comma 2 we will go to two places, that are 0 comma 3 and 1 comma 2, and from 1 comma 2 we get the answer. So we will return 1 from here as well, and 0 plus 1 is 1 obviously, and 1 plus 1 we got 2, and 2 plus 1 we got 3. So total we got 3 ways. So that's what the question is asking for, like from starting point to ending point, like how could you reach the end point? There are three possible ways for reaching the end point. And this is the recursive approach. So obviously the time complexity would be in the exponential, that is 2 power n plus m. This is the code for the recursive approach. We have taken I, that is from n minus 1. And Okay, from I that is equals to n minus 1 and j that is equals to m minus 1, we will return 1. Uh, and if n is greater than n or j is greater than n, then we will return 0. Else return the count path. Okay, so the count path would be like I plus 1, j and m. So how does this I plus 1 is this? This is the I plus 1th part, this 1. And j plus 1th part is this 1. Okay, so we will return I plus 1 j and m plus count paths of I, j plus 1, n, comma n. And in the main function, we will return the count path that is 0, 0, and n, as usual we do. Now we come for the optimized approach, and that is we will using DP. Okay, so DP is nothing. If you have made the recursive approach, then it would be very easy you to apply DP on it. So DP is like we will create grids, like we will first initialize it with minus one, minus one, minus one, and when we traverse through these ways from bottom down, right, or whatever given in the question, we will update the values that 1, 2, or whatever we are doing. Okay, so simply you have to do this. Now the question code is, I will explain you the code. In this function, so this is the function count paths that take the current coordinates, that is I comma 1, I comma j, and grid dimensions are n and m, and a reference to a 2D vector DP for memorization. Now you will ask what for 2D? Like 2D is simply a thing when there are two numbers, two variables or two things are changing, so it would be 2D vector or a 2D DP, or if only one thing is changing, so it would be one, or more than two, it becomes multi. Okay, so this is the 2D vector for memorization. We will do this. If the current cell, that is I comma j, is the bottom right, what does this line states? Okay, listen carefully. If the current cell I comma j is the bottom right corner of the grid, there is exactly one path, the path that ends at this cell. So return 1. Okay, n minus 1, n minus 1 is the last path. So we have to return 1. Now, if the current cell I comma j is out of bounds, okay, beyond the grid dimension, like it has extended n or m, so we have to simply return 0 because that is not even possible. That is not valid. So we have to take care of these things. It won't get out of the box. Now for this, this is the initialization of DP. Means if the value of DP I comma j is already computed and not equals to minus 1, return the stored value. This is the memorization step to avoid recomputation. Okay. As I have told you, there are grids made like these. Like, hello, am I audible? Okay, so in this DP, what we had done, we had initialized minus 1, minus 1, minus 1, and we have updated the values where whichever path we took. Okay, so this is the line, and yes, you have to return DP. That is, if the value of DP I comma j is not computed yet, recursively calculate the number of paths by moving either down. Either down, in this case, I plus 1 comma j was the downward condition, and I comma j plus 1 was for the right. If we move right, then we will use I comma j plus 1, and if we go down, we use I plus 1 comma j and nmm as the size and the DP. Okay, so this was the function. Here we have initialized the DP of m plus 1 vector. Okay, like 2D dp of size m plus 1 into n plus 1 is created and initialized with minus 1. This vector is used for memorization to store the number of unique paths from each cell. Okay, the count path function. Now this is the count path function.
Your screen now visible.
My screen is not visible.
Yes.
Is it now?
No.
Let me check. Is it visible now?
Yes.
Okay, thank you. Okay, so this is the if condition. If the grid is 1 into 1, the result num is returned, and this is the special case to handle the smallest grid. Okay. Now at last we will return dp that is 0, comma 0. For the other grid sizes, the value of dp 0, comma 0 is returned, which contains the number of unique paths from top left to bottom right corner. Okay, and this is the end of the unique path function. Run it. Again, I'm not going to submit it because I've submitted it already more than 6 times. Fine. So this question, we done. Now let's move to the other question. What was it? Reverse pair. Okay, so reverse pair. A hard question, but we will do it. No problem. The problem reverse pair involves finding the number of reverse pairs in the given array. Okay, up reverse pair is defined as the pair of indices 1, I, comma j, such that 0 should be less than equals to I, or j is less than equals to the nums of the size as it is given, and the nums of I should be greater than 2 into nums of j. Okay, for an example, the given array that is 1, 3, 2, 3, 1, the output is 2, like how the output has come. So the reverse pair are like 1, 4, 3, 4, making the output as 2. So I'll explain it. How does it come? So it is not that hard. So we just have to understand like reverse pair. We get it. What does it mean? Reverse pair. Reverse pair means you have to pair reversely, like from the last element of an array. Okay, so we will think like that. From what should be the brutest approach we can think of it. Like we will traverse this element and check every element, like 1, 3 making a pair, or 3, 2 making a pair, or 2, 3 making a pair, or 3, 1. And this will take a lot of time complexity, and we don't have to do this. We have to go for the optimized approach. But before going to optimized approach, we first have to understand the brute force approach. Okay. Uh, so in this question, first, what does this question actually do? Here we have given two output, that is 1 comma 4 and 3 comma 4. Then how does this 1 comma 4 and 3 comma 4 came from? Like 1 is this num set 1, that is 3, and num set 4, that is 1. So look, 3 is greater than twice of 1. Okay, so what you basically have to do, any number, you have to multiply it by 2, and you have to check that number is making pair or it is lesser than in any element. Let's say the brutest approach would be like if I say 1 into 2, that is 2, is lesser than 3. So yeah, it makes a pair. That is a possible pair, and that is 3 comma 1. So this is the pair 3 comma 4. Okay. Now we will iterate it, or we have done minus minus I minus 1, and we reach there 3 comma 2. So in this case, 3 into 2 is 6. Is 6 lesser than 2? No, it is not. So this would not be a case. Okay, then we will again go to this case 3 comma 2. In this case, 2 into 2, that is 4. Is 4 lesser than 3? No, it is not. So this cannot be our case. Now in this case, 3 comma 1 comma 3. 3 into 3, that is 9. Is like 9 lesser than 1? No, it is not. This is also not the case. And in this case, you will take a lot of time complexity, which we really need to, which we really don't need to do this. So I will show you approach. Okay, reverse pair. Let's say this is an array 40, 25, 19, 12, 9, 6, 2. And in this array, you first have to check that I should be lesser than j, and a of I should also be greater than twice of ARR of j. That means if a of I is 40, should be greater than twice of ARR of j. And let's say j is this. Okay, so the twice of 25 is 50. So 40 is not greater than 50. So this can't be the pair. The pair would be like 0, 1, and this is not possible. So we will skip and we will move to the next. That is 25, 19, and then we will move to 19, 12, and thereafter we do this such iteration, and it will take time complexity as n square, O of n square. Okay, so here are some pairs, which are the possible pairs that are 6 comma 2. In this pair, you can see this 6 comma 2. 2 into 2 is 4, and 4 is lesser than 6. Then yes, it becomes a pair. Now in the second case, that is 9 comma 2. In this case, 9 comma 2, 2 into 2 is what? 4. and 4 is lesser than 9. So yeah, it also becomes a pair. Okay, for this, and if we find like going from ith index to jth index, it will take a lot of time, and we don't want to do this. Okay, the interviewer will obviously ask for you the better approach or the optimized one, and generally, no, actually, very rare companies would ask you for the better approach. I will tell you, only the segment companies would ask you for the better approach. Otherwise, they will go for the brute one and the optimized one. Okay, so this is the code here. What does this code say? First, we will run a loop, say I from n minus n. Okay, and then we will select a of I. Also, we will run jth loop from I plus 1 to n, and we will we will apply a if condition that states if a of I is greater than choice of a of j, then we will count plus plus. That's these elements 6, 2. Here here our count would be 1. Here our count would be 2, 3, 4, 5, 6. Okay, so this is how it's gonna work. And then in the main function, you will return the count pair that we have made. Okay, so this is the optimized one. I will show you the optimized one as well. So the optimal is what we have to do. In this case, you just have to think like, what should be the optimized approach? What can we do for optimizing this question? For this question, like there's an array and you have to return it. So the first thing that comes to our mind is the merge thing. Like we can merge the elements and we will return it. Okay, so this is the approach. I will show you how this approach is gonna work. The merge function works by comparing two elements from two halves. Okay, what the merge function works? Merge function works by comparing two elements from two halves. That is the nums of left and nums of right. Okay, so it will compare from these two items. Now, the condition in the question was if ARR of I is greater than ARR of j, that is why we merged the logic. Okay, while comparing the elements, we counted the number of pairs. But in this case, the condition is ARR of I should be greater than 2 into ARR of j, and we cannot change the condition of comparing the element in the merge function. Okay, if we change the condition, the merge function will fail to merge the element. So we need to check the condition and count the numbers of the pairs separately. This is the approach. We will do check for every element in the sorted left half. Sorted, how many elements in the right half also sorted can make a pair. Let's try to understand using the following example. Let's say there is an array 6, 3, 21, 25. Okay, and there's another array that is 1, 2, 3, 4, 4, 5, 9, 11, 3. Okay, here the checking ends at 6. That is 2 into 3. Okay, fine. Now, for the first element of the this is the first element. For the left half, that is left half is 6. Okay, we will start checking from index 0 of the right half, that is ARR of ARR2. This consider this as the left half ARR1 and consider this as the second right half. Okay, ARR2. Now we can clearly see that the first two elements of ARR2 can make a pair with ARR1 at 0, that is 6. These making a pair. How these guys are making pair? It is doing the condition that is 6. If we multiply both of them, it will be lesser than 6. Okay. Now for the next element, that is ARR of 1 at 1, that is 13. We'll start checking from index 2, like 0 based indexing, where we stopped for the previous element. Okay. And this process will work because ARR of 1 will always be greater than the ARR of 1 of 0. Okay, which concludes if the ARR of 2 at 0th position and ARR of 2 at 1st position are making a pair with ARR of 1 at 0. They will obviously make a pair with a number greater than ARR of 1 at 0, that is ARR of 1 at 1. Okay, for the next element, that is 13, you will check after from this index. No need to check from the first index again. Okay, so for this 6, if 1 and 2 has already they already have make a pair, so we don't have to check for the 13. Like for this element, we don't have to check for 1 and 2. We will we will increment our loop or I or j in the third and fourth and fifth and 9, 11, 13, and we will do like this for same elements, like 21. If 13 would be making pair with 3 and 4, and 21 would be like 4 and 5 and 25. Okay, so that's how you're gonna do. I haven't pasted this code. Now, what does this code says? Let's try to understand. Okay, so the first we calculate the midpoint of an array. Okay, first we have to calculate the mid, that is start plus n minus start. Okay, this is the basic, like the very plus point we got in merge functions or sorted functions. There is on the binary search problems, there is a pattern which you have to follow. So keep this thing in your mind. do very well your sorting and searching algorithms, because these algorithms have some pattern, and you have to do code according to the pattern. Okay. So in this pattern, what we have found first, we have calculated the midpoint of the array. Okay. Now we will initialize the pointers for the left half. Left half is I, and for the right half it is J, and the temporary array, that is K. Okay. So this is the temporary array K. Now we will count reverse pair. How we will count it? We will traverse both the half and check for the reverse pair condition. Okay. Increment the count by the number remaining in the left half. Okay. If we satisfy this condition, we will increment the count and we will increment J as well. Otherwise, we have to increment I, and I was the half, first half. Okay. Left half. And J was for the right half. Now it's more clear. Okay. And thereafter, we will initialize it with start, and J would be like mid plus one, as we know we do in the merge sort. Okay. Now we will again check the condition. Now, why this while loop I have applied here? Because merging the two halves into a temporary array. You know how to merge two halves into temporary array. Copy the smaller element from the left half to the temp. Okay, we have copied it, and copy the smaller element from the right half to the temp. Okay, from the right half we have copied it, and from the left half we have copied it. Okay. Now for this, copy the remaining elements. You know, sometimes we left with such elements. Let's say if the length of the array 1 is 7 and length of the array 2 is 8, and we left this one element from second array. So we will also put a while loop for the second element for the second array, and also for the remaining element in the first array. Okay, so this is how it's gonna work. And this the last while condition is for copying the sorted elements from temporary back to the original array. Okay. Now we will go for the void merge. Okay, up merge sort we have to do. So base condition, what should be the base condition? Base condition, if the subarray has 1 or 0 element, it's already sorted. Okay, this is the base condition. If the subarray has 1 or 0 elements, let's say you have 1 element in an array or 0 elements, so it is already sorted and you don't have to do anything. Okay, so let's move. And again, you have to do mid sort. And then in this case, merge sort. Now, what you have changed here, you have mid from start to mid, and from here that is mid plus 1 to end, as we know we do in the merge sort. And then we will merge num, sort, and count and temporary. Okay. And this is the main function to find the number of reverse pairs. First, we will get the size of the array, and then initialize, count, and array bound. Okay. And then this vector, what does it do? It creates a temporary array for merging. And perform merge sort and count reverse pair. This is it. And we will return the count, the total number of reverse pairs. Okay. So let me run it. This is it. Here we go. So this is also working. Not going to submit it. Now we will move to our next question. That is very, very easy. What is it? Yeah, it is two sum, I guess. Two sum. Two sum. This is a very easy question. I guess you guys have done this before many times. And the first question we do whenever we open lead code. Okay. So two sum. What we have to do? There is an array given 2, 7, 11, 15, and the target is 9. Simply the brute force that comes to your mind is actually the best part is the brute and optimized both have the same time complexity. So you don't have to worry about it. And in this array, 2, 7, 11, 15, and target is 9. So what we will do, we will traverse I from 0th index and J from I plus 1, and we will check it. First thing we will check is 2 plus 7 is equals to 9. Yes, it is. So what's the pair? 0, 1. Okay. Now 7 plus 11, is it? No, it is not. 11 plus 15, and we don't have to do this. Okay. And in this case, 3 to 4. Okay. So the target is 6. 3 plus 2, is it equals to 6? No, it is not. It is 5. Let's skip it. Now I will go to 2, and J will be at 4. In this case, 2 plus 4 is 6, and we will return its index, that is 1, 2. Same in this as well. 3, 3, target is 6. You can clearly see that if we add both these elements, we will get the answer, and we will return their indexes, that is 0, 1. Now, I don't think so I need to explain this code, but I will. So we will initialize first loop, that is I from 0 to n, that is num side. and we will initialize the second loop, that is j I plus 1 from 7, okay, to the last index. And we will check it simply if nums of I plus nums of j is double equals to the target, then we will return. Okay, you might ask that what this curly sign is for, which you have to return. Two values or many values would be possible in a list. So we will return curly braces of I comma j, and then we will return if nothing is there, then we will return a empty array. Okay, so this was it. First, to some problem where you can see this. Now we will go for the foursome. But before going to foursome, I guess threesome is important to understand, but I will try my best to let you understand this problem. Okay, there we go. Foursome. So what does this problem say? Given an array, nums of n integers, return an array of the unique quadruplets, nums A, nums B, nums C, nums D, such as. Let's move to the example. Let's say if there is an array given 1, 0, minus 1, 0, minus 2, 2. Okay, and the target is 0. So we have to add four elements for getting the target. What are those four elements? Let's check it out. From this first index, we check 1 plus 0 plus minus 0 plus 0. What's the output? It's 0. Okay, so this is one case. Now we will do this sliding window kind of. Okay, but we are not going to use sliding window for this. In this case, this is a brute-ish approach that you have to tell to anyone you explain it. First, we will go from I, J, K, and L. Okay, that is sorry, that is the optimized one. For this brute one, what do you have to do? You have to just initialize pointer, that is I and J, and you have to check it I, J, K, L. Okay, you can initialize four as well for checking. So you have added all these four elements, and if their sum is equal to the target, then you will return that. Okay, and then again I plus 1, J plus 1, K plus 1, and you move to this part. It is not 0. Let's move to another part, that is minus 1, 0, 1. And this is also not 0. We will move 0, minus 2, and 1. Okay, it is also not. So that's how you have to do. Okay, I wish you are clear with it. So what does this approach say? It's the brute one. Let's check it out. You have to check that I should not be equals to J, and J should not be equals to K, and K should not be equals to L. Okay, and you have to add all these numbers to get the target. This is the brute, and brute has a time complexity of n power 4 that is not acceptable at all. And this is the simplest way that you can explain to your interviewer, that is, we will take set. Okay. Also keep this thing in your mind, like why are we using set? You always know that is set we used to store elements in a set, and it checks that if the element has already in the set or it is not, and it becomes easy for us to get the answer. Okay, so we will be using set in this. So we will initializing a vector set st. Okay, and now we will be using for loop, and because of these for loops, our time complexity is raised to n power 4, and we don't have to do it, but still we need to understand it because you have to explain this in front of the interviewer. So what does this first loop say? We'll go from I 0 to n, and j, as I have told you, I plus 1, and k from j plus 1, and l from k plus 1. And why we are using long, because you obviously know you are using like for loop, and there could be a possibility there are numbers like 1000, 3000, or 10,000. So you have to always take some as long. Okay, so now first you have added two elements like nums of I, nums of j, and then you have summed it up with k and l. And then you have checked if sum is double equals to the target, then you will return a vector in which there is nums of I, j, k, and l. Okay, and then you will sort it, like you just have to sort it, and then you will insert it in the set that we have created earlier. Okay, now you will return the answer. That's it. Hello, am I audible? Can you see my screen as well? Yes. So where we were for some. So this code might sound you like you can't do it, but you will because it's very easy. Let's understand it. How is it easy? So this is the question where target is A and we have created an array that is 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, and a 5, 5, 5. So what do you have to do? We will take two I and J and K and L from last. Okay. In the in this approach, in the brute force approach, what we have done, we were taking I, J, K, and L in the one go, and but in the optimized way, we will take I, J, K from here and L from this. So this will save our time complexity. Okay. So no, what we will use in this now, we need to first understand that what has set and the set we're doing to make our algorithm work without them. So the set data structure was basically storing unique quadruple length in sorted order, and the head set we will be using here is was used to search for the fourth element. Okay, to get quadruplets in sorted order, we will sort the entire array in the first step, and to get the unique quads, we will simply skip the duplicate numbers while moving the pointer. Okay, now we will see how we will skip it. Let's check it out. So, how to skip duplicate number? As the entire array is sorted, the duplicate numbers will be in the consecutive places. So, while moving a pointer, we will check the current element and the adjacent element until they become different. We will move the pointer by one place, and we will follow this process for all four pointers. Okay, for I, J, and K and L. So how does it work? First, we can easily skip the duplicate elements while moving these pointers. Let's say if you have 0, 0 consecutively, you can skip one of them. Okay, and you will check it like -2, -1, 0, and 2. Is it making a pair? No, it is not. We'll again move the pointers. Okay. So now we can also remove the headset as we have to moving pointers that is K and L. That we will find the appropriate value of nums of K and nums of I. So we do not need to headset anymore. Okay. The process will look like this. Okay, so the among four pointers, two will be fixed and two will be moving. So let's say two are fixed. That I have said I and J are fixed, and L or K would be moving. Okay. So इसमें क्या हो रहा है? We will check the sum nums of I plus nums of J, nums of K, nums of L is equals to the target or not. If the sum is greater, then we need lesser elements. So we will decrease the value of L. What I have said, if the sum is greater, okay, if the sum is greater, then we need a lesser element. And so will we decrease the value of L. अगर सम ज्यादा हो रहा है तो वी विल डिक्रीज द वैल्यू ऑफ एल, मतलब कि 2 से हम लोग 1 पर आ जाएंगे. ठीक है. एंड इफ द सम इज लेसर देन द टारगेट, देन वी नीड अ बिगर वैल्यू, सो वी विल इंक्रीज द वैल्यू ऑफ के. देयर आर three cases. First case is if the sum is greater, if we have sum it up and the sum is like sum is going beyond 0, the target was 0 and we are getting 1 or 2. So what we have to do, we just need to lesser the element. So how we will lesser the elements? By decreasing the value of L. Okay, now the second case arises, that is if the sum is lesser than the target. So what we need to do, if the sum is lesser, we need to bigger the value. So we will increase the value of K. Now K will increase it. Okay, for lessing we will do L movement, and for greater we will do the movement of K. And if the sum is equals to the target, we will simply insert the quad, that is nums of I, nums of J, nums of K, nums of L into our answer and move the pointers K. Okay, and we will move the pointers K and L, skipping the duplicate element. Okay. Let's understand the code. What does it say? First, we will sort the entire array. This is it. We have sorted the entire array. So it would be like -2, -1, 0, 0, 1, 2. So that would be easier for us. We will use a loop, say I, this one, from 0 to n minus 1. This I will represent one of the fixed pointers. Okay, you have to keep this in your mind that I is for the fixed pointer. Yes. And in each iteration, the value will be fixed for all different values of the rest of the three pointers. Inside the loop, we will first check if the current and the previous element is same. If it is, we will do nothing and continue to the next value of I. Okay, you get it? Now, for the next for loop, after checking inside the loop, we will introduce another fixed pointer, that is J. J was also fixed pointer. And it runs from I plus 1 to n. Okay, the next element of I plus 1 to n minus 1. And using another loop, inside this second loop, we will again check the duplicate element and only perform the further operation if the elements are different. Okay. Now, inside the second loop, there will be two moving pointers that are K and L. There are the two moving pointers, K and L. K and L are the two moving pointers. Yeah. And K starts from J plus 1 and L starts from the last index. Okay. This is it. K starts from the J plus 1 and L starts from the N minus 1 last index. The pointer K will move forward and the pointer L will move backward. As I have told you, pointer K will be moving in the forward direction like this, 0, then 0, then 1. And L will be moving in the decrease way like 2, 1, and 0. And when the loop will end, it will loop when these overlap their values. Let's say if K becomes 1 and L becomes 0. So in this case, you have to stop the loop. Okay. Now inside this, I have told you. Now we will check the sum. That is, we are going to check the sum. That is, this is equal to the target or not. If the sum is greater, we need a lesser element. So we will decrease the value of L. Okay. Here we have done this. And if we need sum is lesser than the target, then we will need to increase the value of K. That is it. And if the sum is equals to the target, this. Okay. Then what we have done, we have created a temporary vector. And in this, we have stored the values in it. Now we will push back the answer in the temporary vector. Okay. Now we will again do some else if work. That is, if sum is less than the target, we will do K plus plus 1, L minus minus 1. Okay. Finally, we will have a list of unique quadruple length and we will return the answer. Let's run it. It is accepted. Congrats. Now we will move to our last question. That is longest consecutive sequences. So what does it mean? Longest consecutive sequences. It is very simple. 1, 2, 3, 4. This is the longest consecutive sequence. Like you have to just check the counting. The brute force approach that comes to your mind is like you will be checking it like is it 1, is it 2, is it 3, is it 4? You will increase the element or decrease the element. Let's say if you are if this is not a good array, let's say there is an array. If you are at third place, if I is at your third 0, 1, 2, 3, 4. Fourth index, that is 3. So you will check it 3 minus 1, that is 2. Is it present in the array? It is. And 3 plus 1, that is 4. Is it present? It is. And then what will you do? 4 plus 1, 5. Is it? No, it is not. And 2 minus 1, 1. Is it? Yes, it is. So we have created this list that is 1, 2, 3, 4. Okay. And what's the size? That is 4, obviously. Imagine there are no 1, 2, 3, 4 in this array and there is only 100 and 200. So what do you think? Is this going to be the answer? No, it is not. Because 100 and 200 are not consecutive. Because if we subtract 200 from 100 from 200, we will get an answer of 100. Okay. So this is what you have to do. Now the second is num 0, 3, and you have to just first thing that is sort. Okay. You can sort it and check it that your answer is coming like inside the array or not. Or if not sorting, you have to save your time complexity and you have to do something else. So we will first understand the brute force approach. This is a brute approach. What does this approach say? These are the elements 102, 400, 1, 101, 3, 2, 1, 1. Okay. So the count is from 100. If you are at 100, okay. So what will you check for? 101. Then you will check for 102. Yes, it is present. You will check for 104. Is it present? No, it is not. You will stop the loop there only. Okay. Now, if you are at 1, you will check for 2. Yes, it is present. You will check for 3. It is also present. And you will check for 4. It is also present. And what are count? Count, we are increasing it. That is 1, 2, 3, 4. So count is 4 and we will simply return the count. Okay. And it will give us the time complexity as n square. Now we will check it. What does it say? Algorithm is to begin, we will initialize, we will utilize the loop to iterate through each element one by one. Okay. Next, for element x, we will try to find consecutive elements like n plus 1, n plus 2, n plus 3, and so on using the linear search algorithm. So this is the first thing that should come into our mind. Like there should be two approaches that I thought of. I thought sorting should be better, and somewhere I found linear search algorithm is better. So you can go for linear search. So linear search algorithm also plays good work in this in the given array. Now, what you have to do within a loop, our objective is to locate the next consecutive element, that is x plus 1. If the element is found, we will increment it by 1. If the element is found, we will increase it by 1. And continue search for the x plus 2th element. That is 2. Sorry, that is 3. Okay, furthermore, we will increment the length of the current sequence current by 1. Okay, and this process repeats until you will find your answer. So, this is the code. I think it's pretty easy. What does it say? You have given an array num and a vector a. So you will just find the size, that is na the size, and you will initialize a for loop. Yes, and then you will initialize the for loop, that is from I from 0 to n, and you will check a condition if a of I double equals to n. If it is, then you will return true, otherwise return false. Okay. Now in the main function, what do you have to do? You have to initialize the size of an array, and in the longest would be 1. Okay, you have just created one some simple temporary variable, that is 1. And in this loop, you will initialize I from 0 to n, and you will increment it. The more steps you will go. So the x would be the a of I, that is, you will take it as a of I 102, and then you will count it as 1. Now, what we have to check it for? Is there any 103 or 104 there? If it is, then you will increase the count as 2 or 3. And if it does not, then you just simply come out of the loop and you will go I will be 1, then I will be 4, and then you will check for 5, 6, 7. And if it is not present, you will go to 100, then you will check for 101, 102, and you didn't find, then you will go to 1. Now in this case, when you are at 1, you will check for 2. Are you going to find 2? Yes, it is in the array 2 at the index of 0, 1, 2, 4, 5, 6. Yes, at index 6. Okay, you find 2. So the count would be like 2. At first, you have incremented this count as 1. Before that, if you have out of the loop, you will decrement the count as 0, because you are going to start from a new element, that is 1. And the new element, new value of I, you will initialize the count as 1. And if you find the number, the consecutive number, that is 2, again in the array, you will uh, increment the count as 2. And you find if 3 is there, you will increment it as 3. And you find 4, you will increment it as 4. And you will go for 2, 3, 1, and end of the array. And you will return simply the count, that is 4 in this case. Okay. Now the optimized one is this. Okay. So again, we will be using set data structure. As you know, it is used to store unique elements. Okay. In this example, we have seen that 1 is repeating 3 times. Okay, there might be a possibility like 101 could be repeating, 100 would be repeating. So you don't have to take care of that. So simply use set. What set will do? It will remove the duplicate element. It will only store the unique element. Okay, and we will adopt a similar approach to the brute force method, but with optimizations in the search box. Instead of searching sequences for every array elements as in the brute force approach, we will focus on the finding sequences only those for numbers that can be starting numbers of the sequence. This targeted approach narrows down a search and improves efficiency. Okay, how to identify a number if there can be a starting number of a sequence. Now we will move to our code. This is the code. So I will tell you what does the set do. This very easy. If you have stored this first element, that is 102 in this. Okay, so it will check 102 is there. Then you will store 4. You will store 100 and up to 100, 1, 101. Okay, from there. Now you will store 3. Again, if it comes to 2, you will store it because it is the unique element. But now 1 is there. You will not going to store this in the set, because this is the work of set. It removes the duplicacy. Okay, and it will only store the unique element. So you don't have to store 1 in it. And same as the last index, it is also 1. So you will again not going to save this 1 as well. So and in this case, you will be easy to find. Like you have a set 102, 4, 101, and then you will traverse through it, and you can find what's the answer, and you find like 1, 2, 3, 4. That is 4 times. 100, 1, 2, 3. Okay, so this is 3. Now what the question says, you have to just find the longest subsequent sequence. Okay, so the longest is 4, and you have to return 4. You don't have to return 3, because they have asked for the longest, not for every possible consecutive sequence. Okay, keep that thing in your mind. And now this is it. What we have to do in this code, we have first initialize n, that is the size of an array, and if n double equals to 0, we will return simply 0, and we will create a temporary, that is longest, that is 1, and we will use here again set. I have told you that is very important data structure, and it helps a lot. So in this for loop, we will initialize I from 0 to n, and we will insert the element I, as I have shown you in this. like this. Okay, that's how your elements are going to saved in the set. Okay, only the unique elements, no duplicacy is there. Now we will again do an for loop from, you can take it as I or A as well, and it will go until ST, मतलब पूरे set तक ये traverse करेगा. And if ST dot find IT minus 1 double equals to IT ST dot n, let's say if it has find the first element and the last element that is equal, or the value is consecutive, then what you have to do? You have to count 1, and you just have to put the value of IT and X, and again you will find X plus 1. If it is not equals to the end of it, you will simply just increment X by X plus 1 and count by count plus 1, and you will return. Final step is you have to return the maximum out of it. So maximum could be the longest or the count. Okay, so you have to return maximum and you will return the longest, and I will show you. It is running. Yes, it is running. Okay, so this is for today. We are done with all the questions. Thank you so much. If you have any doubt, you can ask me. Yeah, ma'am.